The engines cut off. The landing thrusters die down, dropping from a deafening roar into absolute stone-cold silence. Outside your reinforced viewport, a massive, swirling cloud of fine red dust settles into the thin atmosphere. You take a deep breath. You are officially the first human being standing on the surface of Mars, sitting 140 million miles away from every single person you have ever known. But there is no time for celebration. In fact, stepping outside right now without preparing would kill you in under 90 seconds. Outside, the atmospheric pressure is less than 1% of Earth's, so low that without a pressure suit, the liquid on your tongue and in your lungs would literally begin to boil at body temperature. Before unbuckling your heavy flight harness, you and your crew must execute the most critical diagnostic scan in human history. The absolute top priority? Hull integrity. The intense heat of atmospheric entry, reaching over 1,500 degrees Celsius, could have compromised the ship's pressure seals or created microfractures in the hull. If a leak exists, your precious life-sustaining oxygen is rapidly escaping into the vacuum-like void outside. You stare at the telemetry board as the scan completes. Fortunately, internal pressure holds steady at 100 kilopascals. Step 1 is complete. Next comes power. Your spacecraft's onboard chemical batteries are running on low reserve after the brutal landing sequence. Without immediate power deployment, your life support systems, air scrubbers, and internal heating will fail within 6 hours. Outside, the surface temperature is dropping toward minus 60 degrees Celsius, and the air is 95% pure carbon dioxide. You send a short, encrypted signal back to NASA Mission Control in Houston. Starship has touched down safely, but you won't get a reply anytime soon. At current orbital alignment, radio waves traveling at the speed of light still take over 14 minutes to span the vast void to Earth. Whatever happens on day 1, you are entirely on your own. At hour 2, the landing dust has dissipated enough to begin extravehicular activity preparations. You move to the specialized suit bay. These aren't the bulky, stiff Apollo suits from the 1960s. They are custom-fitted mechanical counterpressure biosuits designed for dynamic mobility. Putting on the suit takes nearly 45 minutes of rigorous double-checking. A single unsealed wrist joint or a microscopic tear means instant explosive decompression, boiling blood, and swift suffocation. By hour 3, your helmet seals shut with a heavy pneumatic click. Your head-up display lights up with oxygen pressure, body temperature, and radiation intake. You step into the primary airlock chamber. The inner door seals tightly behind you. The outer door slides open, and a pale, unfiltered Martian sunlight floods the room. You grab the exterior ladder rungs and begin your descent. Every muscle feels strangely light. Mars' gravity is only 38% of Earth's. As your boots touch the ground, you weigh less than half of what you did when you woke up this morning. As your boot presses into the fine red soil, your brain instantly experiences severe gravity confusion. Your inner ear's vestibular system is sending conflicting signals to your central nervous system. You feel strangely light, almost floating. Yet every sudden motion threatens to throw off your balance completely. A simple jump on Mars could launch you 3 times higher than on Earth. But falling over in a pressurized suit on terrain jagged with sharp volcanic rock is a deadly risk. If a sharp basalt edge tears your outer Kevlar shielding, the suit's pressure collapses instantly. By hour 4, the primary objective on the surface is deploying the main power grid. You drag a heavy equipment sled containing flexible, roll-out solar arrays 50 meters away from the rocket, far enough to avoid engine blast debris during future landings. On Earth, this sled weighs over 300 kilograms. Here, under reduced gravity, it feels like just over 100. The ultra-thin solar sheets unroll across the dark soil like massive black carpets. Because Mars sits 50 million miles further from the Sun than Earth, sunlight intensity here is only 43% of what we receive back home. To generate enough kilowatt hours to keep the mission alive, your solar arrays must cover double the surface area compared to an Earth-based system. By hour 5, high-efficiency power is flowing back into Starship's power banks and life support energy stabilizes. Now, you face the invisible killer, galactic cosmic radiation. Earth is protected by a thick atmosphere and a massive magnetosphere generated by its molten iron core, which deflects dangerous solar flares and deep space cosmic rays. Mars has no global magnetic field and a razor-thin atmosphere. High-energy atomic nuclei traveling near the speed of light pass straight through your suit and into your body. On day 1 alone, your tissues absorb as much background radiation as an average human on Earth receives in an entire year. This is why setting up a radiation-shielded habitat is your mandatory afternoon objective. Hour 6, you unload the compressed HAB module, a collapsed dome structure made from Vectron, a synthetic material 5 times stronger than steel. You anchor the base directly into the hard volcanic bedrock using heavy titanium ground screws. Next, you connect a high-pressure air line from the rocket's reserve tanks. With a loud pneumatic hiss, the massive white dome inflates directly out of the red dust, expanding into a multi-story living space. The habitat dome is inflated, but outside, a brand new chemical threat emerges: toxic Martian dust. Martian dust isn't like soft, rounded beach sand on Earth, because there is no liquid water or wind erosion to smooth out the grains. Dust particles on Mars are microscopic, razor-sharp, and jagged. Even worse, the soil is saturated with toxic chemical salts called perchlorates. These compounds destroy human thyroid function and cause severe, irreversible lung tissue damage if inhaled. Tracking this toxic red powder into your clean living area is a slow death sentence. At hour 7, you execute the advanced suit port protocol. Instead of bringing dusty suits inside an airlock, the suits latch directly onto the exterior wall of the habitat. You open an interior hatch, slide out of the rear of the suit, and step straight into the habitat, without a single grain of external dust entering the facility. The suit stays outside. The toxic dust stays outside. You step into a sterile, pressurized room for the first time on Mars. You pull off your helmet liner and take a deep breath. The air smells distinctly of metallic ozone and clean synthetic filters. For the first time in hours, you can speak directly without using a radio headset. By hour 8, you boot up the Sabatier reactor. Living on Mars isn't just about surviving today. It's about manufacturing your ticket back home. The Sabatier processing unit pulls carbon dioxide directly from the Martian atmosphere, combines it with aboard hydrogen, and processes it at 400 degrees Celsius to produce pure liquid methane fuel and oxygen. Day 1 isn't just a survival test. It is the birth of the first extraterrestrial fuel refinery in human history. By late afternoon, you encounter another astronomical phenomenon: the Martian soul. A single day on Mars is 39 minutes and 35 seconds longer than an Earth day. Those extra 39 minutes completely throw off the human body's circadian rhythm. Your body expects nightfall, yet the sun remains suspended high in the sky. As evening approaches, the sky undergoes a breathtaking, alien transformation. On Earth, sunsets are fiery red because our dense atmosphere scatters short blue wavelengths away. On Mars, the opposite happens. Microscopic dust particles scatter the red light spectrum, while allowing cool blue wavelengths to pass through directly. As the sun drops toward the horizon, it bathes the red canyons in an eerie, brilliant blue twilight. As the blue glow slowly fades over the horizon, Mars plunges into total, unforgiving, pitch-black darkness. Without a thick atmosphere to retain heat, surface temperatures collapse at a terrifying rate. Within hours, the ambient air drops to minus 120 degrees Celsius, colder than any place recorded in Antarctic history. Outside, any exposed liquid water wouldn't just freeze. It would freeze so rapidly that the thermal shock would cause it to shatter like glass. Inside the habitat, life support operations transition into high-power night mode. The facility's internal heating grid draws heavy electrical current directly from high-capacity lithium storage banks. On day 1, heating isn't a luxury. It is critical survival engineering designed to keep sensitive life support electronics, pressure pumps, and structural seals from shattering under thermal stress. Hour 10. The crew gathers inside the primary living module for their first meal on another world. There are no fresh vegetables, hot-cooked meals, or steaks on Mars. Dinner consists of shelf-stable, freeze-dried pouches rehydrated using warm, recycled water. Here, water is the most precious resource in the solar system. Every single drop of moisture, sweat, and exhaled breath inside the pressurized habitat is captured by atmospheric dehumidifiers. It is piped into a multi-stage purification system, passed through high-pressure reverse osmosis filters, and recycled straight back into your drinking supply with 98% efficiency. On Mars, you are living inside a completely closed-loop survival cycle. At hour 12, automated night operations begin outside while you monitor the telemetry indoors. An autonomous heavy rover deploys from Starship's lower cargo ramp, its high-intensity LED floodlights piercing the black Martian night. Its objective? To scrape the top layers of regolith and scan for subterranean glacial ice deposits. Mining subsurface ice is the ultimate key to human independence, providing raw material for drinking water, oxygen generation, and methane fuel. But suddenly, a red telemetry warning flashes on your console. Rover wheel motor stall. The extreme sub-zero cold has frozen the synthetic lubricant solid inside the wheel hub gearboxes. Working fast, you execute an emergency low-voltage heat pulse directly through the motor coils to thaw the internal joint. The gears unlock and the rover resumes its patrol. On Mars, even basic machinery grease can become a single fatal point of failure. By hour 14, you prepare for the crew's first official sleep cycle on an alien planet. You climb into a vertical, heavily padded sleeping bag tethered tightly to the habitat wall. Under reduced Martian gravity, your spinal column decompresses, making you feel nearly 2 inches taller. Suspended comfortably in your sleeping harness, you float weightlessly in a quiet white cocoon, millions of miles away from human civilization. While the crew sleeps, high-energy galactic cosmic rays continue to pelt the habitat roof at near light speed. To protect the sleeping astronauts from cellular damage, the dome relies on a specialized water wall radiation barrier, thick bladders of recycled water integrated directly into the habitat's multi-layered shell. Hydrogen atoms in water are the single most effective shield against heavy cosmic particles, deflecting ionizing rays before they can penetrate the interior. You are literally sleeping inside a protective shield of recycled water. Suddenly, at hour 16, a harsh audio alarm cuts through the quiet living space. Sensor telemetry alerts you to a rapidly approaching atmospheric disturbance, a localized dust storm charging straight toward your landing zone. Wind speeds climb toward 90 kilometers per hour. Because Mars's air density is so low, a 90-kilometer wind doesn't carry the physical force to blow over heavy structures like an Earth tornado. The real threat is friction and static electricity. As millions of fine dust particles collide in the dry air, they generate tens of thousands of volts of static charge. Acting quickly, you switch the solar panel grounding relays to vent excess static charge safely into the bedrock, and you activate the array's mechanical dust wiper blades. Outside, fine sand blasts against the heavy Vectron hull, sounding like millions of microscopic pins striking the outer wall. By hour 18, the storm passes as quickly as it formed, leaving an eerie silence across the plain. Telemetry checks confirm all outer pressure seals held firm, and main power banks remain stable at 72% capacity. You step over to the reinforced floor porthole and look out into the void. Down on Earth, 8 billion human beings are living their lives beneath a warm blue sky. Up here, only 4 humans represent the entire boundary of conscious life in this region of the solar system. Hour 20. The deep space communication link reestablishes as orbital alignments sync up. A recorded radio transmission from Houston Mission Control crackles softly through the habitat speakers. You record your end-of-day captain's log report to send back. Sol 1 complete. Power grid online. Habitat secured. We have survived our first day on Mars. Day 1 was strictly about immediate emergency survival, air, power, and shelter. But Day 2 introduces a whole new level of high-stakes exploration. Tomorrow at dawn, the crew will venture beyond the initial landing perimeter to explore the ancient dry riverbeds of Jezero crater. Billions of years ago, liquid water flowed through these deep canyons. Fossilized deep within these ancient mud layers lies the ultimate question in modern science. Did life once exist on Mars? On Sol 2, you will deploy heavy deep core drilling equipment into the Martian sediment for the first time. But drilling into uncharted alien terrain carries extreme risks. Striking in pressurized pocket of subterranean gas could cause a catastrophic blowout directly beneath the habitat base. Worse still, orbital weather satellites warn of a massive polar cold front sweeping in on Sol 2, dropping temperatures to minus 135 degrees and testing whether your heating grid can endure a full Martian blizzard. Humanity has taken its first tentative step onto another planet. But building a permanent multi-planetary civilization is a battle fought soul by soul. You close your eyes as the second sunrise begins to illuminate the pale pink sky outside. You are no longer just an inhabitant of Earth, you are a citizen of the cosmos. What happens when the crew executes their first deep core drill on Sol 2? Find out in the next episode of our Mars colonization series. If you love cinematic space science and dynamic human exploration, subscribe to Zeoxans, hit the like button, and drop a comment below. Would you spend your first night on Mars knowing you might never return to Earth? Until next time, explore, understand, and evolve.